We want to prove that there's exactly one zero for the following examples. So we have f of x is x cubed plus 4 over x squared plus 7. The interval is negative infinity to 0. There's three things we need. We need the derivative, a negative, and a positive value. The derivative is 3x squared minus 8 over x cubed. We want to pick a negative value, so let's pick negative 5 for f of x. That'd be negative 125 plus 4 over 25 plus 7. I don't really care what this is. That's obviously negative. Now let's pick a positive value. So let's pick negative 1. That's negative 1 plus 4 plus 7. That's 10, which is positive. Okay, another thing to notice, the derivative, 3x squared minus 8 over x cubed, in the interval between negative infinity to 0 is positive, because 3x squared is always greater than or equal to 0. But notice here that 0 is not included, and that's the only place where it's 0. So 3x squared is always positive then. Negative 8 over x cubed, well, it's negative 8 over a negative number cubed. Right? Because in this interval, it's only negative numbers. A negative over a negative will be positive, right? Because negative cubed is negative. So we have a positive plus a positive is a positive. Okay, the derivative is positive, in other words. Okay, so what we have here is at negative 5, it's negative. At negative 1, it's positive. The derivative is increasing. The derivative is positive. Therefore, my function is always increasing. And we're not going to go past 0 because that's not part of the domain. So clearly, it has to cross the x-axis only one time. And that happens between negative 1 and negative 5. Now let's look at another example. So we have g of t is equal to 1 over 1 minus t plus the square root of 1 plus t minus 3.1, and we're between negative 1 and 1. So for this, we need a derivative, always the first thing, and that's just 1 over 1 minus t squared plus 1 over 2 square root 1 plus t. Okay, so this now, between negative 1 and 1, I know that 1 minus t squared is always going to be greater than or equal to 0. It's only 0 at t equals 1, which it's not included here. So that means it's always positive. Okay, so this thing is positive. The square root is always positive, except at 0. Well, when is it 0? That's at t equals negative 1, which is not included. So therefore, this thing is positive. Positive plus a positive is positive. The derivative is positive. The next step is to find a negative and a positive value. So let's consider g of negative 0.99 and g of 0.99. So that would be negative 2.5 and 98.3. Well, if we graph these, and of course these are not drawn to scale, so negative 1 to 1 is asymptotes, since we're dividing by 0. It's increasing, so it should always go up. Now, I made the assumption that the x-intercept is between 0 to 0.99, but I don't really care where it is. It could be in negative. So obviously, it has to be between negative 0.99 and 0.99, and it has to cross it at least once by the intermediate value theorem. And notice the derivative is always continuous here. So that's another thing we should always look at, is make sure the domain is continuous. The function is continuous on the domain. The last one. This one involves a trig function. So this is on the real number line. Finding the derivative is a little tricky because we have to use the chain rule. So bring down the exponent, keep the sign the same, multiply by the derivative of sine, and then the derivative of theta over 3. I can rewrite this part as sine 2 theta over 3. And then I have the 1/3. The reason I can do this is because sine 2x is 2 sine x cosine x. And x here plays a role of theta over 3. So in general, we know that sine is between -1 and 1. If we divide both sides by 3, that means it's between -1/3 and 1/3. And all we have to do is add 1 to all of the sides. To get that 1 plus sine 2/3 over 3, well, all over 3 is between 2/3 and 4/3. Okay, so that means that the derivative is positive, since it's between 2/3 and 4/3. So r prime is positive. The next step is to find a negative and a positive value. So let's take a look at r of 0. Well, we know that r of theta is theta plus sine squared theta over 3 minus 8. Plug in 0, I get -8. I'm going to plug in 30 pi and get 30 pi plus sine squared 10 pi minus 8. Sine of 10 pi is the same thing as sine of 0, so that's 0. And that's 30 pi minus 8, which is obviously positive. Since 30 pi is greater than 90, because pi is about 3.14. So right now I have at 0 -8 and 30 pi minus 8. We said the derivative's positive, so therefore it's always increasing. And at some point, it's going to hit the x-axis, which it's going to be between 0 and 30 pi. And by the intermediate value theorem, there's only one x-intercept.